Chapter 12, it's an outline. Chemical reactions. It outlines about the quantitative chemistry, chemical energy, energy exchange in chemical reactions, fuels, and what are the different types of fuels and its uses, reaction rates, and the factors that affect these chemical reactions. And then finally we're going to conclude the chapter with the oxidation and reduction reaction, and it's a special kind of reaction, the importance of it, and other details we are going to learn in this chapter. It's anything if you have a element or a material which is called A, and if you have another material which is called B, if you are mixing A and B, you are getting a product C which is completely different from A and B, then that is called a product, and then we call that there is a chemical reaction occurred. And reactants are the substances that interact chemically with each other. And products are the new substances that form during a reaction. At first, it seems very simple, but we must begin to consider quantitative analysis of the matter involved in the chemical reactions. So as I already mentioned, if you are mixing A and B together, you are getting a C, a brand new compound which does not have any similarity whether it's a physical or a chemical with A or B. Then we call it a reaction. Aristotle proposed the flammable objects that consist of two elements. One is earth and the second one is fire. Then came Lavoisier, and he was the first one to propose the modern definition. He used careful measurements to establish the role of the mass in a combustion of reaction. So anything burning, then he figured out that the important part we need to consider when something is burning is the mass. And then it came the phlogiston hypothesis, and phlogiston is nothing but a flame. It was proposed by Brincher and Stowe, and the idea that the fire is a basic substance. So not only the earth and the way Aristotle talked about the earth and fire, he also talked about the fire being the basic substance. They contended that the presence of fire was not limited to combustion of reactions. The phlogiston was the mystery substance that escaped during a chemical reaction. So they thought whenever something is fired or whenever something is burned, every material that is being combusted or that is being burned will have something called phlogiston. And whenever we burn, that phlogiston will escape the material and it will go mix with the air. So this thing will happen only in the presence of air, and this phlogiston will go and mix with the air. So that was the hypothesis which was kind of good, got some attention in those days. And phlogiston was the mysterious substance that was escaped during this chemical reaction. This idea may seem absurd to most modern chemists, but it was well accepted and difficult to contradict. So at that time, it was pretty good accepted. And then came the Lavoisier, and he did a series of experiments, and then he disapproved that no, actually phlogiston is nothing but a myth, but also there is nothing is being escaped from the material when there is any kind of a burning is happening. He compared the mass of many substances before and after the chemical reaction. So if something is escaping, so it means it should have lost its total mass, but it is not happening. So that is what was proved by Lavoisier. And he did this experiment like, he put the tin in a container and he made sure that it is burnt. So he saw the mass of the tin before burning and after burning. So if something was escaped, then it could have lost its mass, but it did not happen. So with this experiment, he figured out that the phlogiston is not a correct one and there is nothing leaving the material. So then came Joseph Presley, and he was a minister by trade, and he was an experimental scientist in his spare time, and he discovered some new gas, and the Lavoisier is the one who named that gas as oxygen. Soon it was understood that oxygen was the one which was interacted strongly with a number of other elements, and that is the one which is the reason for all the burning and combustion. And now we are going to look at the properties of oxygen. Oxygen is a colorless, odorless, tasteless gas. It exists in gaseous state at normal pressure and temperature. Atmospheric oxygen is approximately 21%. So when you look at the whole air, almost like 80% of it is filled by the nitrogen and about 21% oxygen, and rest of the air is filled with other gases like carbon dioxide, carbon monoxide, argon, and other gases. And this oxygen is the one which is highly chemically active. So most of the materials react with this oxygen. Nitrogen is most prevalent, that it is 78% present in the air. This means that ordinary air will not be nearly as reactive as pure oxygen. So we might think that, like, since the oxygen is present in the air, so anything should just be combustible with the air, but actually only 20% of the air is filled with the oxygen, and the rest of the 80% is with the nitrogen. That is the reason. So the pure air is not going to be the combustible, but anyways, like, sometimes this could increase the ability though. Whenever oxygen combines with another substance, the process is called oxidation. So that's the oxidation process, and the substance which has undergone a chemical reaction with the oxygen said to be oxidized. So any material that reacts with the oxygen, then that is called oxidized. And the substance that is formed by the oxidization is called oxide. So the material which is formed, it is called something like oxide, something like zinc oxide, sulfur dioxide, things like that. Without realizing it, Lavoisier had performed oxidation experiments while seeking to understand the role of mass in the chemical reactions. Common oxidation process. Ordinary combustion, which is just the simple burning, is an oxidation reaction. The rate of reaction is very, very fast. A slower example. So rusting of iron. So this is also an example of oxidation process, but it is a very, very slow process. So oxidized iron is the reddish brown residue that forms on iron exposed to air. So whenever we leave the iron piece in the regular air, so we see that after a while it just gets that reddish brown coating, and that is nothing but it is being oxidized. Oxides may exist as solids, liquids, or gases. In general, oxides form metals that are solid, and some of the examples of liquid oxides are if it is with the sulfur, it's sulfur dioxide, which is the gas form, and carbon monoxide, it's a gas form. Then another example is carbon dioxide, it's again a gas form. Nearly any element can form an oxide.